Hello guys, hope you're doing well. And as always, if you are new to my channel and have not subscribed to my channel, I would humbly request you to subscribe to my channel so that you'll be able to see all my latest videos that I will upload on my channel, which shall be helpful for your future studies. Thanks. So the problem at our hand is basically we are going to uh, have a problem related to an aircraft service vehicle. Okay, so what does he says? A vehicle. If you look at it, he is telling us that a vehicle for servicing aircraft is shown. Draw the free body diagram so that the forces supported by the members of the lift mechanism due to the weights of the container J and K may be determined. Okay, so in easy words, what is he trying to tell you for this aircraft service vehicle? That this is a platform, a horizontal table platform on which we have these weights J and K are lying, and he is interested in basically they are being this platform is being supported by a machine which is basically made up of two scissor links. These are two scissor links which are being connected by a hydraulic cylinder. This is being connected by a hydraulic cylinder HI. Okay, and you need to basically calculate what are the forces that are being generated in this two scissor links and the hydraulic cylinder as a result of these two weights. Okay, so this is what he is asking in this question. Okay, but before going to the solution, we have to look at this question very critically. Okay, so if you look at it question, and you will see that in this our problem at this point F, at this point the joint F, you can see that here is a pin is being connected. At point C there is also a pin connection. At point E there is a pin connection. At point G, if you see, there is a roller. At point D there is also a roller, and at point basically H, at point H, if you look at it, there is a connection of the hydraulic uh, cylinder. This is a hydraulic cylinder, and from this hydraulic cylinder there is a silverish piston that is being connected to this point A. Okay, and this hydraulic cylinder is connected by means of a rocker at point H. Okay, so this is basically the basically supports that are basically being connected at different points, which are basically being holding this horizontal platform on which the weights J and K are being placed. Okay, so this is and if you look at it, just to make it more uh, clearer, if you look at it, this is your uh, this is your pin. This is your pin. Then if you look at it, there is this is also your sorry, this is also your pin. This is also your pin. Okay, and what is happening here? If you look at it at this point, if you look at it at this point G and at point D, okay, you have a roller. You have a roller. At D also you have a roller. Okay, and if you look at it at point at this point also, if you look at it, you have got a pin, connection, and also if you look at it at this point, okay, if you look at it, this is your this is your look at it, this is your hydraulic cylinder. This is your hydraulic cylinder. This is your hydraulic cylinder. Okay, this is your hydraulic cylinder. And also to make it more clearer, this end point just below this hydraulic cylinder at joint H. Okay, this is, if you look at it, they have placed a rocker. They have placed a rocker over here. Okay, so these are the supports. In order to further understand how they will respond, we can basically go to this chapter, Equilibrium of Rigid Body of R.C. Hibbeler, chapter 5. He says if there is a weightless link, he says if there is a weightless link or there is a hydraulic cylinder or a hydraulic link, it will only give you one reaction. Okay, and that reaction will always be along the axis of the link. This is for the hydraulic cylinder, which is a link basically. Then he says that if you have a roller, he says if you have a roller, if you have a roller, if you have a roller, it will also give you one reaction. One unknown, the reaction is a force which acts perpendicular to the surface at the point of contact. Okay, so we have understood this also. Then he says that if you have got a rocker, okay, if you have got a rocker, it will also give you one unknown. There will be one unknown reaction, and the reaction is a force which acts along the perpendicular to the surface at the point of contact. Okay, so then he says there is another support over here. If you look, go down, and that support is basically, if you look, it is a smooth pin. It's a smooth pin or hinge. Okay, and this smooth pin or hinge will give you two reactions. Okay, two unknowns. The reactions are two components of forces. Okay, so it will give you these two reactions. So once these supports reactions are understood, we can easily go and solve this problem. Okay, we will further simplify it by saying that this is going to be, we can say this is our table. This is our table. Okay, we can say that this is going to be our number. We will say table. We give it the number 1. This is the number 1. Okay, we will give this scissor the number. We will give this scissor the number 2. Okay, this will be given as the number 2 for the solution. Okay, and this one will be given the number. This one will be given the number 3. This will be given the number 3. This will be given the number 2, just to ease our calculation. And this thing, this hydraulic link over here, okay, it can be given the number as 4. Okay, in the last we can say this is 4. Okay, so first of all we go to this table, table 1. Okay, we will say this is the table 1, and if you look at this table, these are the weights which will be acting downwards, Wj and Wk. Okay, these are the weights which are acting downwards on this table. Okay, now here if you look at it at point F, there was, I said it's a pin. See, the pin is given two reactions, and you have given Fx and Fy, and you can assume any direction. Okay, so you have assumed the direction as positive x and positive y. These are our axes. At point G, and you know the roller is there, and the roller will give you one reaction. Okay, which is Gy. Okay, so table 1 reactions are being solved. Now we go to the basically the scissor lift, which is graded as number 2. Okay, if you go for here, this is our scissor lift graded as number 2. Okay, if you look at it clearly, that this was point F, which was being connected with the table, and the point F had these two reactions. Okay, but when we go, this point F is also being connected with this scissor lift, which is numbered as 2. Okay, so when we basically draw the free body diagram of this scissor lift component, you see that Fx and Fy directions are being totally changed compared to Fx, Fy. Okay, because the system has to be in equilibrium, and for this action there is this reaction, thus maintaining the equilibrium conditions. So it has to be mandatory. The direction has to be opposite to that. You cannot take the same direction here, otherwise basically your FPD will be wrong, okay, because the system will then not be in equilibrium. Okay, very important point. This common point E, you have already seen, is also a pin connection. This is common between the two scissor legs. So this, we have assumed the direction EX EY as this, and when you go to point D, you see this is a roller connection. This is a roller connection, and the roller will give you one reaction which is perpendicular to surface at the point of contact. Okay, so now this is solved. Now basically you go to the scissor lift 3. When you go to the scissor lift 3, which is this, okay, this is, now when you go this point G, if you look at it, this is a roller connection, and this roller is give you one reaction over here which is perpendicular to surface at the point of contact. This is the reaction of the roller. When it was here on the base platform, the reaction at D was vertical. Now it is opposite to that. The base is on the top and the roller is at downward. So this is the reaction GY. Okay. Then again, a very important point is coming. When we take the scissor lift connection, this one, when we took this connection, this was the direction we assumed EX and EY. Now watch, when we go here, the direction is totally opposite for maintaining the same conditions of the equilibrium, just opposite to these ones. And at this point, when you go to this point C, you see this is the pin. You have assumed the direction CX and CY. You have the choice to have this direction or the opposite one. That's not a big problem. Okay, you can assume, but for this, it is very important that you have to have these directions for this scissor lift. Okay, so once this is being done, this is being easily understood. Okay, and this was our scissor lift. Okay, the other thing is that if you look at it here, is that this is the hydraulic link, hydraulic cylinder. This is the hydraulic cylinder, and it is being connected at this point I, and this hydraulic cylinder is being basically treated as a two force member. Okay, it is being treated as a two force member. Okay, so since it is being treated as a two force member, so it will have these two reactions. We will assume these two reactions for this two force members. And just for your knowledge, if you are interested in understanding what is basically a two force member, the line of action of these two force members will always be the line directly between the two connections. The shape and size of the member does not affect the direction of the forces. Okay, so this is a two force member. This can also be a two force member. See, these forces are equal in magnitude, opposite direction, and there is no couple movement on them. So these are always treated as the two force members. Okay, so you should know what it is. Okay, so this is basically treated as a two force member, and one, you can see that the rocker was here. The rocker is giving you one reaction. Okay, and if you look at it, this reaction and this reaction are opposite, just maintaining the system equilibrium conditions. Okay, and again, since this hydraulic cylinder, if you look at it from here to here, this thin rod is basically the hydraulic piston. Okay, this is the piston, silverish piston, which is being connected at this one single point, and at that actually point is basically being treated as this point as HY. Okay, this is point treated as the HY point. Okay, so you can basically easily understand these reactions of the keyword diagram of this aircraft service vehicle. Again, these are the weights, and the only thing that is left is these two this vehicle car's wheels. Okay, so this is basically the vertical reaction given by the floor to this wheel, and this is the vertical reaction given by the floor to the wheels. Obviously, the weights is acting downwards, and there will be two similar reactions on the other side because of the symmetry of the wheels. Okay, so I hope you understand this chapter, this topic of how to draw the FPD diagrams of various machine mechanisms, which will be very helpful for you when you're basically solving this chapter, which is coming under the domain of equilibrium of a rigid body. Thanks a lot and have a good day.